Okay, I want to do a couple of more videos about regression before we dive into analysis variance. So let's get started. So this is going to be a super quick introduction to multiple regression, and we'll get a little bit more in the next two videos. So what is multiple regression? Well, we covered simple linear regression, where you predict y from a single variable, x, and in multiple regression, you might guess, you predict y from more than one variable, that is, multiple variables, x1, x2, x3, and so on. And that's super useful because very often in life, I'd say almost always, there's more than one factor that explains something, like what explains why you decide to come to graduate school? What explains your kid's high school GPA? So multiple regression, really useful. So here's how it works. Now remember, R is the correlation of X and Y. So we predict Y from X and we find the correlation. Uh, in multiple regression, you get an equation because it's called y hat, a lot of times the predicted y. So you get a predicted y is a plus b1 times x1. So there's a regression coefficient times the first predictor plus b2 x2 plus b3 x3 for however many x's you have to predict y. So you get a predicted y. And then you correlate that predicted y with the actual y. And that is your multiple correlation, which is shown as a capital R. Now, here's a super simple example. Let's say we have a predicted y, which is 5 plus 3 times x1 plus 2 times x2. So this would be your A, this would be your B1, this would be your B2. And so our x1 for this person is 1, x2 is 1, and so our predicted y is 10. 5 plus 3 plus 2 is 10. And the actual y in this case is 3. So we have our actual y minus our predicted y is -7. And you square that, the difference between the actual and predicted, and you get 49. Now over here we have another person, and this person's score on x1 was 0. Their score on x2 was 2.5. Well, check this out. They also then have predicted y of 10 because you have 5 plus 3 times 0 is 0 plus 2 times 2.5 is 5. So their predicted y is 10. This person's actual score was 17. So you have 17 minus 10, and so they get 7. And so again, you square 7, and again, it's 49. To throw it out there too, I mean, obviously you have a bunch more than 2 points, but your error, if it's the actual correct least squares equation, your error is always going to add up to 0, which is why you have to, your error in prediction, the y minus predicted y, so which is why you have to square it. So here is my not terribly well-drawn regression line. You see that the intercept is 5, right? That's my A. And here is the y value of 3, where there's a 10 predicted. Here's the y value of 17, where 10 was also predicted. So this is my predicted y, and here is my actual y. And as I said, the errors will add up to 0 if the coefficients are correct. And the values of B1, B2, et cetera, other values that will give you the lowest value for the sum of squares error. Now, remember we talked about this before, that the sum of squares, there are, and I'll talk about this again, that the sum of squares, there are two types of sums of squares. There's the sum of squares predicted by the model, and then there's the sum of squares that wasn't predicted, which is the error. And if you check the discussion forum, Sarah, props to her, asked me mathematically how they were calculated, and I even got a chance to go through the normal equations in matrix algebra and explain how they are calculated and how you get those B coefficients. But the truth is, really, we use computer, Excel, SAS, SPSS now. I had a friend in graduate school. I hope she doesn't watch this video. When you're getting your doctorate, you have to take a written exam where they can just ask you anything. And it takes, at least at the University of California when I went, it was a 2-day exam. And my friend comes back afterwards and she said, I failed the statistics portion. And I said, I'm sure you didn't. And she said, oh, I'm sure I did, because one of the questions was, what is the multiple r squared and how do you get it? And she said, I didn't even have the nerve to leave it blank. I just put it's the square of the multiple r, and how you get it is the computer gives it to you. And I said, yeah, I don't think that was really what they were looking for. And she said, no, but the multiple r squared is, in fact, so we'll tell you shortly, the amount of variance in the dependent variable y explained by your regression equation. So yeah, what her answer was, it's the square of the multiple r and the computer gives it to you. That's kind of like telling someone to run faster in a race, like it's correct, but not super helpful. So what r squared is explained variance. So if the correlation between your predicted y and the actual y value, remember that regression line, right, is zero point 0.4, and you square that, and you get 16% of the variance in y is predicted by the regression equation. That is by your predictor variables.